Hi, in this video I'm looking at this problem here where a balloon is being filled with air at a rate of 150 centimeters cubed per second. Assuming that the ball remains spherical, at what rate is the radius changing when the radius reaches 5 centimeters? Now we have this rate here given to us, 150 centimeters cubed per second, and that is volume. Centimeters cubed is volume. So we've got the rate of change of volume over time, dV dt, is 150 centimeters cubed per second. So now we've got one rate. What rate are we after? We're after the rate the radius is changing. So we actually are needing dr dt. We don't know dr dt. So we want dr dt, but I've got dV dt. So I want to write another rate here that if multiply will cancel out the dV but give me a dr. And that's going to be dr dV, because the dV's now cancel out and I'm left with dr dt. But that means I need to work out what is dr dV. Now we need a rule therefore that links volume to radius, and we have that because the volume of a sphere is given by 4/3 pi r cubed. And so we can find dV dr, so we can derive this, which gives us 4 pi r squared. So this is dV dr, but we want dr dV, so we need to take the reciprocal of this, flip it upside down. Dr dV is going to be 1 over 4 pi r squared. So if I go and put this up into my chain rule that I've got up here, I've now got dr dV, which is 1 over 4 pi r squared. And I've got dV dt being multiplied on that, which is 150. So now I have a rule that dr dt is given to us by 75 onto pi r squared. And we want to know what is the value of this, at what rate is this changing when the radius is equal to 5 centimeters. So when r equals 5, what is dr dt? So let's substitute in. That's going to give us dr dt is going to be 75 on 2 pi times by 5 squared. And so if I work this out, this gives us a rate of 3 over 2 pi centimeters per second. Or if we want that as a decimal, we could have dr dt to be 0.4775 centimeters per second. Both of those would be correct. So when you've got one rate and you're after the value of a different rate, but they are related through one of the variables, we can develop a rule and use the chain rule and derivatives to work out our rate that we're after, and then substitute in values and find out rates at different times, periods, distances, whatever is the rate involved in.